Hi class, in this video I'm going to work through some of the most popular missed questions on this past test. This one you needed to find the surface area and volume, and so let's look at the surface area first. And this one is a little trickier to visualize it. Hopefully you were able to maybe even sketch it on your paper, but each one of these dots, so if you imagine these dots like a grid, surface area we are just going to be counting, and so we could go 1, 2, 3 across the top, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so this section right here is 3 times 11, which is 33. Now, this is the tricky part because I need you to visualize this with me. There is a back side back here. It's tall, and okay, and then there's a side over here, and then there's this side. Each of those would be 3 by 11. So we'd have 33 back here. We'd have 33 on this right side that you can't see. And this light green side is also 33. It just jets out a little bit, and so we'll have to go back and count some of these. So if each of the sides is 33, we also need to consider this part that jets out. This front green part, we counted with the other green. And so here's 1, 2, 3, 4, 5, 6, 7 more. Those two that I have dots on the white screen, you can't see those. These 6 have already been counted with the 33. Now if we count across the top, you could also do 3 times 3, but you should see that there's 9 right there. There's also going to be 9 across the bottom, but then we need to make room for this bottom section that's jetting out. And so there's 1, 2, 3 more across the bottom. I've done a lot of counting. All right, we have 4 sides that are 33. We have a top that's 9. We have a bottom that's 9. And then we have these 7 dots that went up the side right here and down below. That was 7. And then we had 3 additional ones underneath that you can't see. Now let's just add those together. You get 160 square regions. All right, next. And what I'm going to do is encourage you just to cut this piece off right here. So here's that little piece. I'm not so good at sketching it, but here's that little piece right there. And then we have this tall piece. So let's find the volume of the tall piece, add it to the volume of the small piece. All right, if we're looking at the small piece, it's actually easier just to count the small piece. We could go ahead and use the formula, but do you see that this small piece, and I'm going to look right back here on this original shape. Do you see that it's just 1, 2, 3, 4, 5, 6 blocks kind of just glued to the front of that? And so the little one is 6. Now to find the taller one, let's go ahead and use the formula. Volume is base times height, which is capital B is the area of the base. Let's just call this one up here the base, and that area is 9. We determined that from previously because it was 3 times 3, and we determined that the height is 11 because remember, definition of the height is from base to base, and so it's 11. 9 times 11 is 99 plus 6 to get a total volume of 105. Next question, these are 2 triangles. Both are looking for the area and perimeter. Area is 1/2 base times height, or you could also look at it as base times height divided by 2. Either way is fine. The most important thing that I want you to know about the base and the height is that it has to meet at a right angle. So right here on this first one, there is our right angle. There's our perpendicular lines. And so to find the area would be 15 times 30, and then we'll take half of that, which is 225. Next, the perimeter is just this blue line, 3 sides, and so it's 18 plus 25 plus 30, and that would be 73. Next question, this one is a little tricky. Here is your triangle, and it's given you some extra numbers that are really just there to try to trick you. This 29 is our base, and this 9 is our height. What's tricky about this is this 8 millimeters here. That's information that we just don't need to have. It's not part of the base because it's a dashed line. It's just showing you that 9 is perpendicular to where the base would be. So we are actually multiplying just 29 times 9 and then divide by 2, and that's 130.5. Okay, next is to find the perimeter. Now I have it drawn out in this green marker here. The perimeter is 29, 38, and 12. Again, the 9 and the 8, those are dashed lines. Those are just measurements. Those are not part of the triangle. Add those together to get 79. Okay, in these two problems, we're also finding the area of the shape. It would be best to take these from the computer screen and sketch it out on a piece of paper, and then you can do the partitions. So if I am going to just draw 2 vertical lines, and now I have it separated into 3 rectangles. If we take a look at this first one, do you see that it is 12 by 6? Okay, so this first triangle is 72. All right, so let's talk about this little area right here, this square. Okay, we know the entire top here is 24, but we can see that there's a 6 and a 12 already part of that 24 because of just properties of a rectangle. Opposite sides are congruent. And so there's already a 12 and a 6, which together that's 18. And so this missing piece right here must also be a 6. And then next, to find the height, we know this entire height is 12, but then part of it is already 6. And so this part must be 6. So we're working with a perfect square in here, which is 36. Okay, last shape is this big one over here to the far right. We know across the bottom it is 12. And we can say this side is also 12 because opposite sides of a rectangle. And so 12 and 12 is 144. Those are the areas of the individual parts. We're just going to add them together to get 252. For part B, there's a couple things that we could do. The first thing that comes to mind is just to make triangles, but now we have a rectangle and 2 triangles. If we look at this first triangle, it says from above that this section is 14, that this is 6. So that part's easy. We can just say 14 times 6 divided by 2 is 42. If we look at the big triangle, we can also get its measurements. So if we look here, okay, this 6, this height that I'm circling in red, it is directly across from this height, and so we can assume that it is also 6. Next, right here, this is where 14 ends, and it ends right where the other triangle starts. And so if the whole piece is 28, 14 has already been used, that means this distance right here is 14. Now, this is a tricky picture because it doesn't look like those 2 triangles are equal, but in geometry, you can never trust the picture. And so this is also 6 times 14 divided by 2, which is 42. Now we're left with the big rectangle across the bottom. It is 28 by 6, because if with the top half is 6, the bottom half has to be 6 because the entire piece over here is 12. 28 times 6 equals 168. We are not going to split that in half because this is a rectangle, but we will take 166 plus 42 plus 42 to get a total of 252. Okay, next are these dot shapes, which can be confusing, but the best thing to do is to draw a grid by connecting these dots. So that's what I'm going to do with this first one. All I'm doing is just connecting dots, okay, and I'm staying inside the shape. So just from the dots that I have connected, okay, so I've connected these like a grid, and from the ones that I've already connected, I'm just going to count the full squares. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm going to say 11 full squares. And now we have these triangles. The best thing to do with these triangles is you can first eyeball it. Okay, you can see that each of these triangles are half of a full square. You could also use the area of a triangle formula. So for example, if we're looking at this triangle right here, its base is 1 and its height is 1. And so 1 times 1 divided by 2 is 0.5. Okay, and then we could take that to each triangle, which I'm not going to do each individual one, but all of those would have 0.5. We have 1, 2, 3, 4, 5, 6, 7 triangles. Oh, it's not 7 triangles. I forgot one right here. So that's 8. So 8 times 0.5 is 4, and that gives us a total of 15 for this first shape. All right, now I'm going to go straight here to B. I'm going to do exactly the same thing. I'm connecting all of the dots. Now from here, I can recognize that I have a couple bigger triangles. Let me highlight these bigger triangles for you in red. So right here, I have a big triangle. Right here is a big triangle, and then here's a small triangle. which we can assume from problem 1 that that is 0.5 because it's 1 times 1 divided by 2. All right, this one in the middle, it is 1, 2, 3 high and 2 across. 3 times 2 is 6, divided by 2 is 3. Same over here, 1, 2, 3, 4 by 2 is 8, divided by 2 is 4. So there's my triangles. Now I'm just going to count the full squares, but I'm not going to include the squares that are inside of the red triangles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to take all those numbers and add them to 12 to get a total of 19.5. We're going to do one more. I'm going to do the same method with the triangles. I'm going to identify the bigger triangles first. I have a triangle right here on this end, triangle here, and then let's see how I want to do this. So let's start. Okay, all I've done is just partition all of them off into squares, except I decided to leave these shapes on the arms just to be a parallelogram, which is still base times height. And then here I have 2 little triangles. So if we talk about the triangles first, base times height divided by 2, these little blue triangles are 1 times 1 divided by 2, which is each 0.5. These large red ones are 2 by 2, which is 4, and then divided by 2 is an area of 2. The yellow parallelograms are base times height. It has a base of 1 and a height of 1. So 1 times 1 is 1. Now let's just count the remaining squares. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So I have 22 plus the 2 red triangles plus the 2 yellow parallels and then the 2 small triangles, and then add those all together to get a total of 29. Next, this is also area of a triangle. Again, area equals base times height divided by 2. And so we're going to let AC be the base. And so we have 1, 2, 3, 4, 5, 6 across the base. And then the height, remember the height has to be perpendicular, which we don't have right now. And so we could drop a perpendicular line from B, and I'm going to dash this line because it's not part of the triangle. But if we counted B until I got to this level of 6, it'd be 1, 2, 3, 4, 5. So it has a height of 5 and a base of 6. And so this one is just 5 times 6 divided by 2, which is 15. In this case, these ugly radicals, square root of 29 and square root of 89, those were just there to try to get you off path. You did not need those to solve this problem. The problem says that the diameter of a circle is 12 meters. So that means the radius is 6 meters. You're going to have to just think about this one. This one's a little tricky. We're going to use the center of the circles to make a square shape around that mysterious shape here in the middle. Okay, we don't have a formula to find that shape, but we can draw a box around it, and each of the sides of the square is also going to be 12 meters because it's 2 radii put together, one from one circle and one from the other circle. And so the square is 144 meters squared. And to get to that white funky shape in the middle, do you see that we need to subtract these quarter circles right here? Just the area of these quarter circles. Well, if you have 4 quarter circles, do you see that that really means just one full circle? Okay, so the area of one circle is pi r squared. And so if we use 3.14 times 6 times 6, that is 113.04. And now we're going to subtract these two to get 30.96. And I think the original problem, I must have not copied that part. I think the original problem said to round up. And so this would just round to 31 meters squared. So that's all for this video. If you had a test question that you missed that I did not go over, please let me know. Send me a message and I'd love to work it out for you.